Thanks, Manoj. Good morning, everyone.
Good morning.
Hope you had a groovy morning and have a great day. So, my talk is about reactive programming with RxJava and Groovy. Before I start, let me quickly understand how many of you know Groovy. Okay, most of them. How many of you have already worked on reactive programming of any sort? Not many. Well, so this will be an introductory talk on reactive programming. The objective of this talk is to introduce reactive programming concepts, not focusing too much on RxJava as such. So, I mean, the RxJava is very vast, and I mean, the time is, you need a lot of time to cover it in detail. But if at all we get an overview of what reactive programming is all about, I think that purpose is served. So, what's reactive programming? So essentially, it's about working with the streams of data. So it could be synchronous, asynchronous, hot streams, cold streams, any of those. In this talk, we will see only cold streams, not hot streams. But that should serve the purpose of introducing. So let's start with an area what you are already familiar with. Let's say okay, so that prints. Essentially, you are working with the list here, right? So, how does how do you iterate through the numbers in a list or any collection for that matter? What happens under the hood? Anybody? So essentially, it's say let me create a class called say numbers, which has to implement an iterator. That's it. And you have to implement as next and next. Let's say state here. Say start with 1. You have to increment the number and return it until say less than or equals 5. That should be enough. So how do we use it? Yeah, that prints numbers up to 5. So this is how iterator works internally. Look at the way the call happens here, right? The client, the user of this iterator, it is calling the method next, has next, next, has next, next. So essentially, what you need to understand here is that it's a pull-based model, right? The client, the code here, the line number 23, it's asking for give me the next, give me the next, give me the next. So once it say has next return false, you know that all the whatever numbers are available here or all data available in the stream is exhausted and we are done. With this example, let's move on to reactive mode. Right? So the basic construct, before I use that, right now I'm using RxJava version 1.0 something. I'm using it through through a library called RxGroovy, which was initially required to pass closure as an argument to RxJava functions. But these days it's not really required. And also a new version of the API has come, RxJava 2, which actually implements reactive streams specifications. You might have known JPA, right, Java Persistence API, but typically Hibernate came first, then the JPA was evolved, right, out of Hibernate, Toplink, etc. Similarly, RxJava came into existence first. Later on, they found out there is a need for standardization in the API. That's why they introduced Reactive Streams API, and the RxJava 2 implements that. So there will be few changes here. But if you happen to be interested in using RxJava in Grails, it will be still with the 1.x. So I'll stick to that. So, yeah, so the basic construct is observable. Let's say numbers. I have just created an observable, I haven't put any logic there. Then to use the observable, you would need a subscriber. So in this case, it's already given me the templates for uncompleted, on error, on next, etc. On next will be very similar to on next what you saw in iterator, right? So let me just print that. Subscriber of integer. Yeah, to make it clear, we can always put integer. Let me just print that number. So let's do something similar what we did previously. I took numbers up to 5 and printed that. So to the closure, let me just call it as subscriber, rather than using it. And let me say subscriber on next. And I'm just passing that one. Ignore other two methods for the time being. Now let me say subscriber dot. So I've just created observable and subscriber. Now we have to link these two. called it as numbers, right? Yeah, numbers dot subscribe, and you have to give a subscriber. Feel free to ask questions whenever you have. Let's see what happens. Subscriber. Correct, right?
Okay, so we have to write dot each where we have passed a range.
Oh yeah, correct. Because it's just creating a range there. Yeah, it's going to print here. But the problem is, previously we knew how, when it ended, right? So now look at the way it starts. So it starts with observable here. So 1 to 5 each time. Whatever the subscriber we have, we call on next day. Right. So the main difference to be noted here is, this is a push model, not a pull model. Previously you used to call next. In this case, you just subscribe to an observable, right? Attach. This is an observable and this is a subscriber. And observable will push and it will notify that, hey, here you have the next item. So how will the subscriber know that it is completed? There has to be a notification, right? So let's say once it is done, say I'm done. Let's go and put a message. Just complete. Now you know when it is done, it is going to say it is complete. Now say I'm trying to get the numbers one by one here. Say there are 10,000 or 1 lakh numbers there, and I'm looking for something specific. The moment I got the number, is there any need to continue there, receiving the next number? It's not really required, right? So you can say that I'm done. I don't need I don't need any more data. I want to unsubscribe. Let's do that. Let's just leave it as. So it prints that. Now say if number is say 4, right? Say unsubscribe. I don't want that. Let's just run this and see what happens. It still gave 5 because our observer didn't really bother about checking if subscriber really wants next data or not, right? So that is the responsibility of observable. So now to do that, check subscriber say when it is not unsubscribed, I'm going to send that. So now it is stopping at 4, and the moment it is done, say it is completed. So that's how you unsubscribe. So I think here complete also you should say essentially if you don't need to send complete to somebody who is already unsubscribed. Now, every time things don't go right, bad things happen. What happens in that case? what would have happened, say this is a simple, we are just iterating through numbers, but in your typical projects, you'll be getting the data from files or database or maybe making a call to API, and the data is not just a simple number. We are just, to demonstrate, we are just taking the simplest possible example, right? So what happens in such cases? Yeah, exceptions are thrown in that case. So it's very easy if it is a pull model, because every control is on the caller, so he can handle the exception and do something. But in this case, right, it's the observer, which is, it's a push model. So if at all some exceptions occur while generating the data, how do you communicate that to the subscriber? That's why we have on error. Let's say and let's take a really simple. So typically exceptions would occur here while generating the next, I mean it can occur anywhere else, but this is a typical place, right? So let's say number is 8. New see some runtime exception. It's just on 3 error would be called, but this is not good enough because it is for the entire thing. You are not able to recover from this in this case, right? Whereas if you want to typically handle, you would put a check within this. Say runtime exception in this case. I'm not going to do anything here, but instead I'm just going to say subscriber on error, and I'm just going to pass the exception. I mean, behavior should be same, but the level at which you handle error should be something like this. Okay, so that's the basic model, wherein you have on next, you have a way to signal completion, and you have a way to notify errors. Currently, I mean, with these examples, all of them are running in a single thread. Subscriber and observable, they are not running in a different thread, but the a real life example, most probably, that is going to be the case. That is, they are going to run on different threads. So any questions?
Yes.
Yeah.
If you look at line number 43, right?
Mm-hmm.
Scroll up. Yeah. So if you remove that if condition, you can still send an uncompleted message to a subscriber that's still not there.
Right.
Okay.
Which is a waste actually.
Yeah, so the question is, if it's unsubscribed, why did the onComplete message still work? If you uncomment that out, it will still show 1, 2, 3, 4, still show onCompleted, but the subscriber was never there, right?
So yes.
So if you remove the exception and go back to the original state.
Sorry, I should do this. That's a mistake. Should be is unsubscribed.
Okay.
Right. I think that should be the same thing. Groovy.
In spite of that if condition, it will still send the message.
No, if I put this check, it won't send, right?
Right. But the question is, why is the condition even required? Because if it's unsubscribed, the message shouldn't even go through, right?
Well, I think, see, everywhere you are going to handle that case, there is nothing available out of the box here. So, you specifically say now you send, this is the error case, or this is the completion case. Similarly, this is the complete case.
So it's more like just checking flags, that's it.
That's it.
Okay.
So I'm not sure if there are any improvements in the newer versions. Check.
Why does it not complete after error?
Error, yeah. Once it is error, it's not going to complete. That's you don't know whether that's the case. If it is required, you'll have to again subscribe and get it if that is the case. So if you want to restart, that could be another case. Maybe. Yeah, so that's a very comprehensive look of the API with the subscriber and observables. But some of the cases you really may not want to handle. You think there is no need to handle error because everything will be perfect, right? So in such cases, there are more convenience methods available. So you can always say observable say from. So in this case, I'm creating an observable from a list. So there are quite a few convenience methods like that. From existing types, you can create an observable rather than going through the very complicated procedure of putting everything there. But that would be more essential in case of hot streams. Cold streams, this would be fine. Right. And there are quite a few other variations, like wherein you can pass in two closures, where the first one is for the second one is for the error, etc. There are a few variants which you can check in the documentation. So let's move on to the next part of where we operate on observables or we perform certain operations. So let's do this. So let me move that to 10. So I hope you understand what the closure does. Anybody?
We're just figuring out the event.
Yeah. So the closure will check if the argument is even or not. If it is even, it will return true. If it is odd, if it's not even, it will return false. That's going to be. So filter will you might have already used Groovy specific way. It will be find all. Right, which will return all the data that satisfies that criteria. Let's do this. So it's going to print only even numbers. Now let me say I just want to do a map, and I just want to multiply it by 2 or double it and return it. So all numbers are double here. And suppose say I want to reduce it or calculate, find out sum of that. So I can use reduce. So it's going to do that. So the interesting part here is you can compose them very well. So I'll just put filter, map, and reduce one after the other and run. It's going to. So even though reactive programming can be done in a different way, right? So the RxJava chose it to do in more functional style. That is because you are going to get the benefit of composing here. So you have this filter, map, reduce, all these are operations performed on observable, right? Observable is a stream. So you can have these closures are declared independently, defined separately, and you can reuse it. Right, and whatever operation you want on observable. So essentially, each one will return another observable. Right. So let me just do this to get better insight of this. So do even or same closure. I'm just extracting it there. Nothing's okay, let's start with one. Okay, next we want to do this, and let's see. So I have an observable from the numbers, and I'm just going to do a filter. Within the filter closure, I put a message so that we know whenever that gets called. See, nothing is printed. So what it essentially means is that the function, the closure is even never got called. What it implies is that observables are lazy, right? Unless that element, that operation is really required at the end, it's not going to be used. So you can compose any series of operations on the observables, but if that is not really required, it's not going to evaluate that. So it's following a lazy evaluation, which is another major benefit of this.
If it is creating this stream of operations, and if we have to call a terminal operations to perform those calculations,
Exactly.
as it happens in Java 8 stream.
That's right. Yeah. So the idea is this. So you can always, any operation can always, you can say it works on an observable, right? So where that observable comes from is it doesn't matter. So you can create from some of the available data, or you can use it from the result of another operation. So the statements previously what I wrote, map, filter, and reduce, I've just changed in line. Instead of that, you can have different functions doing that, which in turn return observables, and you compose them later. So that whenever you have a very complex operations on observables, inline is not a recommended way at all. So essentially you would have them defined in each function, so that whenever you want to change that aspect, the change is only in one place, single responsibility. Any questions?
So can we convert any stream into observable?
You mean to say Java 8 streams? Or?
Yeah.
I'm not sure if there is any integration specific available, because RxJava is compatible with Java 6 also. So if at all you want to get benefit of, say, lazy part of it, and you have to use Java 8 streams, there's no option to use older versions of Java. Whereas RxJava, with RxJava you can use it with even versions 6 onwards. That's another benefit. There are quite a few differences also apart from that. Okay, so let's take one more example where the complexity slightly increases. So let me start with the same numbers. Let me use group by. So what would happen in this case? I'm calling group by on an observable and checking for a condition. The result of it is either true or false, right? So it checks if divided by, is it divisible by 2 or not. So essentially outcome can be 2. So this will be the elements from this observable will be grouped into 2 streams or 2 observables. Now if I want to perform some operations on that, essentially I have to call flat map. So I have to call flat map, and I would say it's a group numbers what I get here. Now say each one is, we have split that stream of numbers into two streams, right? One is stream of even numbers, another one is stream of odd numbers. So that is what is getting passed as numbers here. And say I want to reduce that. And number, or rather, or I can put it as count. So each number I am counting one. How many even numbers are there? How many odd numbers are there? Then let me say return something. Yeah, so numbers is a group. So key will say whether it is true or false. So true will be what? Even, right? And false is odd. And finally I am printing the count. So this ends here. On that I can subscribe. Let's see. So just to find it. So now we should get a difference. By mistake. Yeah, now you see there are 5 odd numbers and there are 4 even numbers. So there are quite a few operations how you can split one stream into multiple stream, and then again you can combine that. You can say I'm going to take the greatest maximum number in each position, etc. Or I want to take based on the time dimension. Whatever number comes within 1 second, I'm going to take the greatest of that. There are quite a few options there, on the way to combine multiple streams. I'm not going to get into the details of that. But essentially, this is how using group by you split, and using the flat map you apply some operation on each of those substreams, I would say, and combine the result and get it back. Let's go back to the from just take that, say I want a map. We have done. Let me put a message here also. Now. Nothing wrong. Oh. Okay, so these two I have, or let me just put even is enough. Particular one of them should be enough. Printing. So printing is the subscriber part, and whereas the computation is the okay. Keep this. Yeah, so in all the examples previously we saw everything was running on a single thread, but that may not always result in good performance or good utilization of resources. Instead, we want to span multiple threads and let's take advantage of that. So let's say subscribe on, and there are already few thread pools available. Say we'll take computation thread. Let's just check if it works before calling that. Yeah, so it's running on main thread, right? So now let me change that. I am running it on computation thread pool. Yeah, now you see, it's running on computation thread. Right. So essentially, I mean, the subscription part doesn't run. Whatever operations are getting performed. When you say subscribe on, those operations are getting run on computation thread. Similarly, we have one more, observe on. Schedulers, let's say IO. That's how you would, you can use observe on and subscribe on, and use any thread pools. You can give your own thread pools as well. How much time do we have?
5 minutes.
Yeah. So I'll yeah. Questions, please.
So I have one question.
Yeah.
Which method is calling print number? The closure print
Sorry.
number.
So essentially, this should thanks for that. Okay.
You might want to put printer and 996.
Printer is not there for printing mode.
Oh, sorry. Yeah, now you can see. It's running on the same thread. Right, one should be before. So essentially, so before doing that, I should put this. Yeah, so printing on so thread 1, right? And checking is on computation thread 3. Yeah.
One more question.
I think yeah, that's that part is the name is a bit confusing. Subscribe on is essentially yeah, right. That's where subscription the is even runs, right? So it has to be given before that. If you provide it before map and say then give that, so there is no more computation, no more observable part. It's only the subscriber part which is run. So yeah.
One more is about this on this page, the group by thing. When we split observer into 2 streams, okay. So
Not necessarily 2. In this case, it happens to be 2. Yeah.
in this case, so a subscriber can have 2 subscription if we just put subscribe after group by. So is it like my subscribe is now subscribing 2 different observers, or it is still
One at a time.
one at a time?
Right. So you may run these in 2 different threads, and that subscription may parallelly go on. That can happen. But since you have split it into 2, at some point in time you may want to do something, right? Otherwise, you may say parallelly you send it somewhere, and later on that gets segregated somewhere. That could be a possibility. But
So 2 observers can push into same subscriber.
it's 2 different. Right? Class can be same. The code is once, but the instance is multiple times. Yeah.
Just a plain question really. I'm just trying to make sense of why to get to this model of programming.
Yeah.
Some basic benefits for any project
Yeah.
or with existing code in mind.
Yeah. So yeah. So essentially what happens is, say for example, you have a server, right? It could be a web server, and which is serving requests. Say which is the response is quite huge, and what happens typically is that your clients can be slow or fast. The rate at which they process could be very slow or very fast. They can vary. So what happens is you can take a couple of examples. Say for example a temperature, right? Say server is capable of sending temperature every second or every millisecond, every microsecond. The client is slow and it's not able to process at that rate. So this is typically called as back pressure. So client can indicate that this is the rate at which I can process. I can't process it at a higher speed. So essentially server server doesn't have to create a lot of response and buffer it. That means the more slower clients you have, server memory will be full really quick. So you're not wasting memory just like that. Rather, if you had produced the results slowly, you would have served more clients with the same results. So essentially, it's about better utilization of resource. And again, again, what rate you want to get it, and what size you want to get it at a time, etc. Yeah, which is applicable typically on a hot stream, not on a cold stream. So this is, say, if you have numbers from 1 to 100, it's always going to be the same. It's not going to change. But temperature, typically you can say that at a time you send me only this much. That is for handling the size. And if it is about the rate, say temperature, say instead of every second, I just want one reading per minute. That could be a solution. Yeah, this is just the basics of that. And again, comparing with Java 8, this is where you get to use schedulers and run things on different threads. So it's really efficient if you have a lot of I/O tasks. So as part of processing. Whereas Java 8 streams will be more operating on in memory, wherein you want to leverage the benefit of lazy evaluation. But say you are going to have 10 different tasks, 10 different web services. So it's possible that one web service itself is consuming all the threads, and other services are getting starved because of that, which can really happen with Java 8. Whereas here you can have different thread pools and you can allocate them to as per the need. So some tasks can have more threads in the pool, and some less important tasks can have fewer. So in a way you are making use of resources in a better way. Any more questions? Well, I've run out of time, so thanks a lot. I hope you found it useful. If you have any questions, feel free to contact me. Thanks.